Hello, hello. Welcome back to our weekly stream. My name is Sohan Maheshwar. I'm a dev advocate at Fermion. Joined again by Radu. Radu, we haven't seen you in a couple of weeks. How was KubeCon?
KubeCon was amazing. Hi everyone. It was so nice to get back and meeting a lot of old friends and getting to meet a lot of new people in the cloud native community. So I really enjoyed KubeCon. I think it was personal opinion. It might be the best KubeCon I've attended in maybe 3 years, and I don't think I've missed one in a long time. So I'm really happy with this KubeCon. It was great.
Awesome, awesome. So good to hear that. In case you didn't, or in case you missed it, folks, a lot happened for us in the time between KubeCon and now. We announced a bunch of cool new features, including Spin version 2.0, which is what we will be talking about today. In case you missed it, here's a blog post on Spin v2.0. So many cool things that it actually enables, including things like the component model, which is what we will be talking about. So Radu, what do you have in store for us?
Yeah, I thought that for the next few minutes we'll just go through the announcement blog post for Spin 2.0 and try to look at what is new that we could do with Spin 2.0 that we couldn't before. And we'll specifically look at a couple of things. One, we'll have a look briefly at the manifest changes between Spin v1 and v2. And go through the new build up experience for getting started with a new application. And then we'll look at two things that we could do now with Spin 2.0. One is streaming. We'll have a look at a preview for how you can stream data from your Spin application by looking at a very simple Rust application that takes in an HTTP request and then streams data on the response body as it becomes available. And then look at a fully featured component, the Spin file server that we've been building on for a while now, ever since we released Spin. And first look at how it's been adapted for Spin 2.0 and how it takes full advantage of streaming, and have a look at a real world example there, and then see how we can compose it with, for example, a Python application. So for example, taking full advantage of the component model and the composition side of the component model, and look at how we can take pre-built off-the-shelf components and integrate them in our presumably other type of components written in another language, and just use its functionality there. So I'm happy to dive into various other parts of Spin, how Spin works, what's new in Spin 2.0. But that's the plan for the next few minutes. And so
Awesome.
I'll try and share my screen.
Yeah. Well, Radu does that. Well, welcome back to the stream, everyone. Let us know where you're tuning in from. If this is your first time, well, thank you for joining in. If this is not your first time, well, thank you for coming back. The cool thing is we will be learning about streaming while we're streaming. Ha ha ha. But yeah, Radu is going to tell us about one of the new features of Spin v2.0, which is the ability to stream data. Right? Yeah, Radu, take it away whenever you're ready.
Excellent pun. Okay, so at the beginning of this month, right before KubeCon, we published a blog post on introducing Spin 2.0. And essentially, what we've wanted with Spin from day one has been to create this new kind of application, and this new kind of application that uses WebAssembly at its core, and takes advantage of all the advantages you get from WebAssembly, like really small artifacts, and entirely portable across operating systems and architectures, and that start really fast and that can run anywhere, and build a coherent developer experience and a coherent way for people to build applications. And then with our efforts with Fermion Cloud and the work we're doing in Kubernetes and Nomad and other places, a really compelling platform for running these applications at scale. So with 2.0, our goal has been to crystallize some of the work that we, together with the WebAssembly community, has been doing on the WebAssembly component model and component composition. Have a look at performance and making sure that Spin can serve a lot of concurrent requests and behaves really well at scale. And then one important thing for us has been from day one that you can build applications with Spin, but you're not required to just run them with Spin alone. So in 2.0 as the first version, that you can build a WebAssembly component and then just run that with something else that is not Spin. There's no Spin involved, and that two some things is one is wasm time serve. You can build a WASI HTTP component with Spin and run that with wasm time serve. And then the second is Nginx Unit has a technical preview for running WebAssembly components in Nginx Unit, and that's the second that we might have a look at the end if we have enough time. Basically building a tiny component and then running in all three environments that I just mentioned, including Spin. And then finally, we've done a little bit of work on the ergonomics of our developer experience, in particular for things like SDK ergonomics. So if you're a fan of Rust, we'll have a brief look at what's new in the Rust SDK in V2 and all the new ways you can build applications. And we've aggregated a few more capabilities in the Spin application manifest around outbound HTTP and outbound Redis and outbound. Essentially, any outbound host connection is now tightly controlled by the outbound hosts field in spin.toml. So with that, what I wanted to do is just go through the experience for creating a new application, building it, and then running it locally with Spin 2.0 and seeing what's new. And then we will dive into doing some streaming in Rust. So I've waited for this is stream number 4, I think, for 4 or 5 for me, and so I've waited enough to go do something non-trivial with Rust, and so this is going to
finally
be yes.
Yeah, I think again in the comments, let us know if is there any Rust fans here. Last time, Radu, when I think you were coding in TypeScript, we had people saying no, do Rust. So here we are.
Yep. So if you're going to developer.fermion.com and you select the Spin tab, you will now find a switcher between V1 and V2 documentation. So if you're still on Spin v.1, the CLI, then you can switch to the old documentation. We strongly recommend everyone to go to Spin v2. There's a lot of improvements behind the scenes and in the CLI ergonomics that I think make it worth to update to Spin 2. We wanted to be sure that any application that worked with Spin v1 should continue to work with Spin v2. So if you find anything, if you upgrade your Spin CLI and you find applications that didn't work with 1.5 or earlier, let us know that. Let us know about it. So with that, let's take Spin for a spin. And I configured Spin v2. We have Spin v2.0.1, which we released a patch right after releasing Spin. You can find it in the Spin documentation in 201. There were a couple of performance regressions in upstream wasm time that we identified and fixed in the process of launching Spin v2, and then a few SDK ergonomics that we addressed. As always, if while you're installing Spin, if you want to verify that the binary artifact that we uploaded is the real one, we do have a way for you to do signature verification. So for every Spin release since 1.0, I think, we include the cosign verification. So strongly recommend you run this as part of your Spin configuration process, just to make sure that it's really us who built the version of Spin, and you can actually find the actual GitHub workflow that built this version of Spin. So if you're interested in diving into that, that's in.
I just want to shout out our engineering team and you, Radu, for having this verification, the identity verification feature. I think it's pretty cool. I know a few people in the community also have, complimented us on it. I think it's nice that we have something like this. On that note, Holy Odin's here. Welcome back, Holy Odin. Haven't seen you in a couple of weeks. Welcome back. We actually launched Spin v2.0, which has some features like the component model, the ability to stream data. So that's what we're doing on this stream. Yeah, thanks for joining.
So closing the loop on the signature verification, if you're, we have two places where you can use cosign together with spin. The first one is to just verify the spin binary. So if you really want to make sure that the binary we built is ours and built by our GitHub Action infrastructure, we include this with every spin release. But then we have a way to sign and verify spin application themselves. In particular, because we use standard registries to distribute spin applications, that means you can reuse all of the infrastructure that you might already have around signing container artifacts with spin applications. So if you use notary, notation, or cosign in this case to sign OCI references, you can continue to do so, and it's going to use the you can use the OIDC flow in cosign to just sign using your GitHub identity if that's something you want to do. So whether you're interested in signing and verifying the spin binary or signing and verifying your spin applications that you distribute your applications with, that should be possible and documented for both Spin v1 and v2. So I highly encourage people to have a look at this. Okay. Now that I have Spin 201 locally, I'm just going to do Spin templates install just to make sure that I have the latest templates, and then Spin new. Now it's no longer required that I specify both the name and the template directly, so I can choose the template. I'm going to choose Rust for now, and then I'm going to streaming.
Nice one, Radit.
You know,
I see what you did there.
Yep. So, okay, we created a new application called Spin Streaming, and let's have a look at what happened here. We have our spin.toml file, and our manifest looks slightly different than before. We now have a top-level manifest version that is now at version 2. And now we have an application field, and then we have a trigger array here. So this is the starting point for us being able to support multiple trigger types in your applications. That's not yet possible with 2.0, but we hope that's going to come really soon, so that if you have an HTTP component and a Redis component or some plugin that provides a new trigger type, we really want to make sure that eventually you're able to define all of them in the same application. That's going to come at some point in 2.x lifetime. So we have the same kind of metadata as before. We need a name for our application, version, authors, and then a description. Our trigger configuration, it's a simple HTTP application that will handle pretty much everything. And the component that handles this route is called streaming, which we define right here. And if you're familiar with how the component manifest looks for Spin, this is the same information as before, slightly rearranged to make it easier to modularize. We have an issue, a feature request in Spin to be able to split this component, this application manifest across files. So that should be coming really soon. And this way of splitting the application detail, splitting components and triggers this way, should give us the starting point for all of that. So what follows here is basically the configuration for our components. It's supposed to load the component found at this path, stream_streaming wasm. After we've built the application, this component is not allowed to access any HTTP hosts, is not allowed to access any Redis endpoints, MySQL, Postgres, anything that's that includes outbound networking connectivity is not allowed from this application, from this component. And then we have our build configuration that tells it that the command to build this application, this component, is cargo build target wasn't 32 WASI release, which will end up generating this file. And then whenever we run spin watch these file patterns. So watch cargo toml and watch any .rs file in source. Spin watch will automatically watch spin.toml, so you recover there. So that's the changes. If you look at the difference between how quick start did we have? Yep, this is v2. If you look at how v1 looked like, it's same kind of information, slightly like splits the trigger configuration into its own config, and then the rest of the component configuration minus trigger separately. So no big, no foundational changes yet, just slightly rearranged information. Spin v2 should be able to run a v1 manifest with no problems. So if you have existing v1 applications, they should continue to run.
Mm-hmm. Yeah, and folks, if you aren't part of our Discord already, make sure you join it. You can look it up on our website or just go to our blog post here and join it. We've been having some great conversations about Spin v2.0 and the sort of possibility it enables right now. So yeah, do check out our Discord. Also, hi Marvin. Naming is hard. Completely agree. I think that could be the name of our stream, quite honestly. Like just naming is hard. Help us with variable names throughout. But yeah, just thanks for joining the stream, Marvin.
Yep. Naming is hard, and I may be known for coming up with very silly names, and so I would very much welcome people helping me name things. Cool. Once you've built your when you have scaffolded your application, now it's time to look at a very, very simple Rust handler. Takes in a request. This time it returns a result of something that implements into response. This is in response to how difficult it was to pass the right kind of shape for your response body. So if you wanted to, response bodies used to be option of bytes, and getting a simple string or a simple type into an option of bytes involved a lot of conversions, a lot of things there. And so Ryan worked a lot on making sure that this is more ergonomic than before. And so now you can just pass a body, which is just a string. So you don't have to do anything in particular there. And so hello live stream. So spin build. So we did spin new, spin build, the same experience. Nothing changed in terms of the CLI experience there. So everything should work exactly as before. And now spin up should curl. Yep, hello live stream. So nothing here changed compared to before. So now that we have this out of the way, TLDR spin v2 should continue the experience for creating an application, building it, and running it locally should look just like before. Now let's have a look at the first of the new features that we're making available in Spin 2.0. And we'll just look at, well, we can look at performance plus streaming, because that's something that I'm kind of excited about. So if we look at a little bit into the blog post, performance, streaming, and WASI HTTP. So in Spin v2, we've basically, for the HTTP environment, for the HTTP incoming HTTP handler, we've rebuilt the infrastructure around handling HTTP requests to be built on top of WASI HTTP, which is an incoming standard for both incoming and outgoing HTTP requests in WASI. So it's a WASI specification. The implementation for it is in progress in the Bytecode Alliance in Wasm time. We've decided to build on top of that and make it available in Spin 2.0 and in Fermion Cloud, and just battle test it to make sure that the standardization process is going well, and just try it out before it becomes a real standard. And so in Spin 2.0, all the components that you generate, all the components that are executed using quasi-HTTP. And one thing that quasi-HTTP brings, which is why we were very excited about making this available, is quasi-HTTP defines a standard for how to stream data, to how to stream incoming request body and how to outstream outgoing response bodies as well. So we're essentially having a broad look at what it means to run real world applications, and streaming has been a really important part of this. So if you're interested in making sure that you can start returning the response as soon as it becomes available, even if the server hasn't finished processing, then Spin 2.0, and in particular the Rust SDK, makes it possible for you to start sending chunks of data back as soon as they become available. So what I wanted to basically do over the next few minutes is have a look at how we can essentially just take a file, and instead of loading it and buffering all of it and assigning, allocating memory for all of it and then sending all of it back, just reading chunks of it and then sending it back as a streamed response from your application. So we'll just continue our very simple Hello World application, but instead of just leaving it at Hello World, we want to just load a random file from here and just start sending chunks back. So let's see how we want to do that. One thing that I know is I think we will need, because this is Rust, we will probably need the futures crate in Rust. So let's just start a new pane here. Cargo add futures. And it added 0.3.29. That should work. And at this point, if you're familiar with the LSP server Rust analyzer, it requires a restart. Once you add dependencies, I could have done LSP restart, but safer to just stop it and start it again. The second thing that we want to do is this function signature is the standard one. It assumes that you're taking in a fully read request and returning a fully formed response. And being able to stream means we won't have the full response just yet. And so I'll just do that for now and start from scratch and basically build a very simple handler that is able to handle streamed responses. So HTTP response, HTTP component, and then function, let's call it handler. This one will have a slightly different signature. Incoming request, and it will return, and it'll also have a response. And we'll just keep it simple for now and just do that. And it's also asynchronous. And then let's do another async function stream that just takes the same parameters. So stream and just returns a very simple response result. And we want to use anyhow result here, and this one does return okay. And what we want this handler to do, just stream eight dots. We're gonna have a lot of error handling along the way, and so this was just easier than doing unwrap every single time. So if the stream function fails, we'll just panic and return the error. So, okay, what we want to do, going back to our original goal, is just stream a file. So first and foremost, we have to decide the chunk size that we want to return. So let's create a const.
And Radu, is this something that's mandatory to do before you decide on when you're streaming data, like define a chunk size that of the data that's being streamed?
Yeah, you do have to decide that. Essentially, once you start getting data in, you could just stream it. And if you don't want to decide the chunk size ahead of time, you could just return arbitrary length data, but you have to set the header as well with the chunk size. So this is just convenience to, we're going to use the chunk size to both read that many bytes from the file and then return them. So we're going to use this for both purposes. So let's just go with 1 megabyte, which is absolutely entirely arbitrary. And I'm just choosing it as usize. So we have a chunk size, and now what we need to do is read a file from disk and then return it. Before we do that, we have to create the response. So we can do something like, and if you want to follow along, the example here is more or less representative of what happens. So create the outgoing response parameters, which basically contain just the status code and then any headers that we might have. I'm just going to create a new header and just not pass anything in there. And I think we are working to make this as more ergonomic as we continue iterating on a streaming API for this. This is a preview of how you want to do streaming. So if you have thoughts and feelings about this kind of API, we would love to hear them. So let's take the body from this, and now we should be able to use the body to just add data to it as we read it. So and last we set the actual response once our execution finishes to be the response parameters we just defined. So including the parameters and then the body. So at this point, we've done the handshake for taking a request, creating the parameters, and then defining the body. And at this point, all we need to do is read a file. So let's use Rust to just open a file. Use standard file, file open, and now we have to choose a file here. I'm just going to choose whatever, spin.toml, or let's see, target. Ideally, we want to either, so what I want to demonstrate is instead of sending the entire file in one go, that we can read chunks of it and send it back. And so I'm going to choose a file that is larger than the chunk size so we can see sending multiple chunks back. And so okay, so what we need is target wasm32 wasm release. and then the name of the WASM file, which is we're just gonna send the actual WebAssembly file back.
I'm going to give a quick recap for those of you who just joined. I saw like a couple of people have just joined the stream. We launched Spin to v2.0 very recently. This was during the week of KubeCon, which I think was a couple of weeks ago. So Radu is just taking us through the example in this blog post. And one of the features of Spin v2.0 is the ability to stream data. So that's what we're doing right now in a Rust program that's compiling to WebAssembly. As you can see, we have defined on line 13 a chunk size of the data we're streaming. We're reading a file. In this case, we want to see a file that is bigger than the chunk that we're defined, only because then you can see how each chunk is streaming. So right now on line 21, Radu is opening a file, and we're going to read from that and then stream it.
So basically at this point, we just create a buffer that we will over and over read from the file into that buffer until the file is read entirely.
Radu, we have a question from Marvin, which is the path absolute now?
The path is that's an excellent question. The way it is defined right now is absolute, and that was going to be an error. So thank you, Marvin, for spotting that. It should be relative to where Spin, where we start this, from where Spin starts the application, and relative to we will have a files field here that defines how we want to map the files from the real file system for our Spin application. So here we will have a files field that will contain, now basically have the mapping between the destination, which is supposed to be the target directory, and our source that we'll have a look at in a second. Excellent catch there. So
thank you.
Okay, so we'll create a buffer of size chunk size, and then we can just iterate through our entire file and read until there's nothing left in the file. This is a very, very simple example, and when we're done with it, we will have a look at a real file server that actually does streaming and is built and tested, and we've been using for a while now. And so you're not supposed to do this manually unless you need to return to be streaming. You can just have a look at a pre-built server, file server component. But if you are interested in, if you do have data that is amenable to streaming and chunking and sending chunks back, then this should be interesting. So let's just do file read, and what this this function needs is a mutable buffer, which is why we defined a mutable buffer here. Read, and now we should have Intel sense. So it requires a mutable buffer, which is what we created earlier. Mutable buffer, and I think we want to tell it that it should use all of them. Maybe. Okay, let's see. We're not using this just yet. So this should give us the number of bytes that we just read from the file. So if you read the documentation for standard IO read for a file, it pulls some bytes from the source in a specific buffer and returns the number of bytes that we just read. And so this one should literally just go open the file and read, in our case, these many bytes. So what we want to do is, if we actually return 0, which means the file is now done, because there's nothing else left in the file, then we want to break, because we have an undefined loop here. So if we do read 0 bytes, we want to break. Otherwise, let's get the data out of the out of the buffer. And there are other ways you can do that in Rust. I'm just reading B bytes from the buffer because it's not guaranteed that we actually read the entire chunk size. The file might have fewer bytes left than the chunk size. And then you can do body send data, and it needs a vec. Okay. No. Sync, and we have send on a body is of type, something that implements a sync of vec of u8, and so that's why it takes a vec of u8, which is the data that we just read from our buffer, which was read from a file. So at this point, this is a chunk of data that we have available from our file, and whenever we have some one of those chunks, we could just call body.send, and this will continue to send send data on our stream for our body. So finally, let's just do a print that says send a new chunk of size b, and and I think this should be it, ideally. So just recapping what happened here. We take an incoming request, define the shape of the outgoing response with the status code and whatever headers we have, and then start reading open the file, and then iterate through while reading the file. If the size of the number of bytes we read from the file is 0, then we exit, break the loop. Otherwise, take the B number of bytes from our buffer that we just read into, and then do body send. The crux of this entire function, which is what a few lines of code, is take the body, take a mutable body, and then execute body.send every time you have new data available. So you can imagine how you could stream data from various locations, and so that's the main thing that you need to do. Now let's have a look at this line, and Marvin correctly spotted that it was wrong before because it was opening an absolute path, but right now it's supposed to open a relative path into target wasn't 32 WASI release, and then the file we want to read. If we try to run this right now, let's do a spin build to see if the run directory. If we do a spin build, it finished building. Let's try to do a spin up, and this should handle every request. So whatever request we send, curl looks to 3000, and it tells us failed to find a pre-opened file descriptors through which wasm32 WASI, our streaming file, could be opened. And that's a code name for you're not allowed to actually access that file. And we would have had the same error if we were trying to open an absolute path or a relative path. It doesn't matter. And that's because in our spin.toml, we are not allowing this component to open any file. And so what we need to do is set a mapping between files that are available on our disk right now. We could actually look at the file here, but it's not available for our WebAssembly component. And so what we need to do is grant it access to it. So there are a couple of ways you can do that in Spin. If you go to the documentation, files where running Spin application. Okay, where is that? I think it's in writing. Including files with components. There we go. So there is this file section in the spin.toml application manifest that allows you to mount or map application files from your file system into the WebAssembly application, and whatever is defined in this files section will be distributed with your application when you push it to a registry. So there are two ways in which we could define this. One is with a how do you call this? A pattern, wildcard pattern of including whatever in a given directory, or in a much more granular way, having a source and a destination field. So what we want is source is, well, because I was lazy and I opened the file using the local relative path. I just want to open source to be the current working directory, and then destination, I want it to be at the root of the file system for application. So technically, now the entire application should have everything we have in our file system available. So this directory should be mapped inside the application. You can have a much more granular way of doing that, but this should be enough for us to do a spin up now. And instead of doing a curl, because this returns a file, I'm just going to do a wget instead. I'm in the wrong directory. And we could actually see here how we are returning chunks. But let's do that again. We've saved it as index.html, but it's in fact a WebAssembly file. So if you look here, there are 3 iterations of that loop where we send 1 megabyte, 1 megabyte, and then slightly lower than 1 megabyte. And if you look at the file size, it is 2.2 megabytes. And so we've managed in this application, instead of allocating, of opening the file and reading all of it in one go and allocating memory for all of it, we're now able to just, instead of that, decide on smaller chunks, which means significantly lower memory that we need to allocate ahead of time for our app, and which means the client can just receive data as it's available. You can stream pretty much any kind of data you want from this. It can be JSON files, it can be binary files, images, whatever you might have, and you could do it the same way. So
Radu, we have a question from Marvin. Is the Spin host runtime sharing file descriptors via WASI with the instance, or what is the no pre-opened file descriptor error message hinting at?
Yep, that's correct. So behind the scenes, Spin is built on top of WASI, the WebAssembly system interface, and that is a specification and an implementation on how a guest application, in our case, our WASM file, can access things like files, environment variables, network sockets, anything else. And so we control that here, and basically make those file descriptors available at runtime. We basically map those inside the WebAssembly instance, and then that instance has access just to those file descriptors. So unless you specify that here, then your WebAssembly module, your WebAssembly component does not have access to anything. So that's the capability and granular capability aspect of how Spin uses WASI behind the scenes.
Yeah, nice. Marvin also says, but please no detour. I do not want to sabotage the stream with questions. But Marvin, but that's the point. You're supposed to sabotage the stream with questions. Again, like keep the questions coming. We love to hear from you. And that's the whole live coding experience, I think, right? Where, folks from the audience, you all tell us what you all want to see. Radu, I actually have a question at this point of time, right? I think we had people who just joined us. For a quick recap, we're talking about Spin v2.0. and the ability to stream data in your new Spin app, right? And Radu just showed us a demo of how to do it. You can go back in the stream and check it out. Radu, what possibilities does this open now? Right, we know what WebAssembly is good at, and serverless and server side. Now, the fact that you can stream data with the Spin app, what are some of the possibilities that opens up?
The simplest and the most convenient one is in Fermion Cloud, for example, we have a limit on the amount of memory you can allocate in your WebAssembly application. And so you should be able to start sending responses that exceed the amount of memory you can allocate in an application. And so just hypothetically, if the limit was 10 megabytes, it's not, but if the limit was 10 megabytes, the maximum size of the file you could return was 10 megabytes. Now you can return a file that exceeds that just because you can chunk and stream responses back. And so first and foremost, it's a very important web platform capability that you should be able to stream responses for large files, as opposed to waiting for all of it to accumulate and then send a big chunk back. So anything that has to do with serving static files and large binary files should be significantly improved because of this. And then the other nice thing about all of this is if you have a server operation that takes a long time to process, the time between your client application becoming interactive and getting data now is just the time to get the first chunk, as opposed to waiting for the entire response back. So if you have, for example, a query in your database that takes a really, really long time and returns 10,000 rows or 50,000 rows, you can start sending those chunked back, as opposed to waiting for all of that to finish. So those are just two very simplistic examples of things that you can do that this makes available. And I do want to point again that all of this is built on top of WASI HTTP, which is the WebAssembly WASI standard for defining how HTTP works. So this, I urge people to have a look at WASI HTTP. This is the underlying standard that makes all of this available in a standard way for applications. The other cool thing that you get with WASI HTTP is, for example, you can have an incoming request and start streaming data to an external API as it becomes available, and then start streaming back as it becomes available, as opposed to waiting for the hop both times for all the data to be available. So this is a way to speed up interactivity and speed up the time between your server starting to send the response and your application being highly responsive. So with that in mind, I mentioned along the way, while manually writing this in Rust, that we have built a file server component that I've been showing you developer.fermion.com, and I've showed you www.fermion.com. All of these are served and are executed through this actual WebAssembly component that is a file server, not unlike, it's very, very similar to what we've written here in a few lines of code. It just has a little bit of robustness around reading the data type and setting headers with the MIME type and all e-tags and caches and things like that. But fundamentally, it's a file server that reads a file from disk and returns it as an HTTP response. And so if we have a quick look at that, it's just that. It defines the headers and reads all of that. But finally, once it creates the setup for it, it just does that. It takes a buffer, read it, and then sends the body. So it's really what we've built is a very, very dialed down version of our actual file server component that we've been running in production. It's been serving Fermion.com for a long time now. I think 18 months at this
Right,
point.
yeah.
And all other websites that serve our content. So this is a real component that if you go to fermion.com right now, you will execute the WebAssembly module, WebAssembly component that does exactly that. But that's not all of what you can do with the file server with Spin 2.0. So in 2.0, I mentioned streaming and performance as being one of the things we were interested in. The second thing that we wanted to make sure with Spin 2.0 is possible is enabling component composition. And that means that so far in Spin, if we have a quick look at our spin.toml file, our source continues to be a single WASM component file. But what we want to do is be able to compose multiple of these WebAssembly components and use functionality from one, import it and execute it in another, and basically put together components written in different programming languages. You can build Spin applications in JavaScript and Rust and Python and other languages. So ideally, you should be able to write some business logic in JavaScript and have a high performance streaming library that returns files written in Rust and be able to put them together and use functionality from one to the other. That is one of the promises of compiling to WebAssembly, of the component model, and of what you should be able to do. And so in Spin 2.0, we are starting to lay the foundation for all of that. So if you go into the Spin file server repo, you'll notice there is an examples directory here. So if you go to github.com fermion spin file server, there is this examples directory that shows you how to import this file server component that is very similar to what we've done here. So this is able to stream files and do high performance streams and chunk files and send chunks as they're available in languages that may not have streaming enabled just yet. So we haven't had a chance to update the Python SDK, for example, to enable streaming, but we can do that nonetheless. If you look at the README for the example here, what we've done with this is give you the ability to import the Rust file server component in a different language that compiles to WebAssembly and import that component and its functionality, put them together, and then run them as a single unit. So you should have instructions on how to run this. But essentially, if we look at the example here for a second, there we go. This is our handler function that we've defined and built in Rust earlier, our handler component. And then what we can do is write a very simple Python program that knows nothing about how to stream files, has no knowledge whatsoever of what exactly happens there. What it knows is it takes an incoming request and returns a response, but has no idea of exactly what that component what that component does. And so what we can do here is import the incoming handler as file server, and then in our Python application, in our Python component, just handle this request and hand it off to the WebAssembly component that we've built before in Rust to do the file streaming, read the file from disk, and send chunks back. So let's, if you're interested in the actual source code for this, this is the most important part of all of this, incoming handler handle. So we can do a spin build.
This thing is so exciting for me. Just the ability that you can write like a Python piece of code to talk to something that was written in Rust without it knowing too much about each other. I know. Am I the only one who finds this super exciting? I do.
Being able to do polyglot component composition is something that we've long wanted to be able to do. And the way the component model is built and the way we've added support for it in Spin 2.0, it's finally starting to to be a real possibility. And so there are still so many things that they want to do and so many ways in which we want to improve all of this. But what we wanted to make sure in Spin 2.0 is that we have the ability to showcase and yep, I already am running Spin on this one.
Yeah, and quick shout out if you check our YouTube channel, because you're obviously on our YouTube channel, we do have some explainer videos about how polyglot programming works, right? Our CEO Matt has done some very like explain like I'm 5 type polyglot programming videos and how the component model actually enables this. So yeah, check it out.
So we had a brief look at our application, our Python code. The important thing here is incoming handler, and then the file server handles the request. It literally passes the execution to our Rust component. The important thing here is we do the same thing that we did earlier. We map a directory and we make the files in that directory available for our new application. So if we in static, we have 2 files. Foo bar. And so if we start the application, curl foo.text, at no point in our Python component we had to read a file, send a stream back. All we had to do here is file server handle, and we delegate that request to the file server component. So what I'm going to do is I'm going to add two very simple print lines to our application, just to make the point here of this is actually a Rust component. Hello from the Rust file server. And here.
Yeah. And Marvin also shares my excitement with the polyglot programming and the component model. Fully agree, Marvin. I think it is magical, and I think what's important to remember in the WebAssembly space in general is that it is evolving, right? So what we are seeing right now is just scratching the surface of what will be possible very soon. So yeah, super exciting.
So what we should see now is hello from the Python component and then hello from the Rust component. So that's basically our execution goes from the request handled initially by our Python component, which then imports and executes and calls the Rust file server. So at this point, you can imagine how you can put together examples in various other languages. So we have an example in JavaScript where you can call that Rust component. We have an example in Python that we just looked at. We have an example in Rust where we can just import that other component. And as this progresses, as the component tooling and as language tool chains and as language ecosystems update their ability to execute components and to link components together, you should be able to basically pick off-the-shelf components and import them in your application in similar ways. The tooling and the invocations and the commands to actually link these components together are using a tool called Wasm Tools Compose, which basically takes the pre-built Rust file server component and our Python component that imports it and statically links them for now to generate one self-contained component that contains every single WebAssembly component that we need. we are working really hard, and hopefully we'll have this available soon, where this doesn't generate a statically linked binary, where you can actually execute and dynamically link components at runtime. There are a lot of possibilities that this opens up, and if you have thoughts, suggestions, requests on things that you want to see, I'm looking forward to hearing those in our Discord server. Everything that I showed, you can read through the write up in the Spin 2.0 blog post, and then since then, I think at least Kate wrote an article in detail about composing components. She has another example with an OAuth middleware. So basically, instead of implementing OAuth in every single component, there's a way to do middleware with this mechanism. So she has an example there, and then there are a few other examples around how to make this available. Matt also wrote a very forward-thinking article around how to use this functionality of being able to compose components and stop re-implementing every single library in every single language out there. So if you're interested in that, I recommend you have a look at those resources.
Yeah, for sure. I think there's lots of interesting articles about the component model, the ability to polyglot program, and yeah, definitely check out Matt's article. It's called "It's Time to Reboot Software Development," and many interesting ideas put forth there. For folks who joined in and followed us with the stream, especially Marvin and Holy Odin, thank you so much. Radu, do we have anything else for today's plate?
No, I think I went through most of the things I wanted to show. I'm looking forward to figuring out what I want to do next. If people have suggestions, opinions, requests, I would love to dive back into building something real as opposed to showing functionality. And so if people have thoughts about what we can build, I would love to learn about that and to just build something together.
Yeah, let us know in the comments if there's anything specific you want us to tackle or explain or show a demo of. Radu can do it all. And for folks who just joined in, yeah, if you want to follow the code of the stuff that we did today, well, there is this video, but also you can check out the code on fermyon.com/blog/introducing spin v2, right, with the hyphens. All of the code samples are there. You can just follow along. And if something pops up in your mind later and you're like, ooh, I should have told Sohan and Radu this, no worries. We are super active on our Discord. It's a great community. We're very inclusive. We have a code of conduct as well. So pop in by our Discord group and Discord group. Man, I think I'm growing old, Radu. I just called it a Discord group. Oops. Our Discord server. And yeah, just let us know there as well. That's also fine.
IRC or other...
ICQ.
Yes.
Yeah. All right. Okay. I think that's the end for the stream. We will be back next week as well, where we will be building more on Spin. Until then, thanks so much again, Radu, and thanks everyone for joining in.
Thank you all for sticking around. See you next week.
All right. Bye.